Next, I can calculate the total current now that I have the potential V1 and the total impedance. My current total is going to be equal to V1 over ZT. That's 2 volts over square root of 2 at an angle of 30 degrees over 14 14.492 plus 2.714 J ohms, and that gives me a current, if you do it on your calculator, of we have 0.096 amps at an angle of 19.392 degrees, or that would be 96 milliamps at an angle of 19.392 degrees. I1 can be calculated because this potential is directly over the resistance, across the resistance, so that's I1 is equal to V1 over R1, and that's 2 volts divided by square root of 2 at an angle of 30 degrees divided by 15 ohms, and that equals 0.094 amps at 30 degrees. Or we have 94 milliamps at 30 degrees. I2 is going to equal V1 over our capacitive reactance, and that's equal to 2 volts over square root of 2 at an angle of 30 degrees over our capacitive reactance was negative 30.315 J ohms, and that gives us a current of 0.047 amps at 120 degrees. That's 47 milliamps, 120 degrees. And I3 is equal to V1 over inductive reactance, and that equals 2 volts over square root of 2, angle of 30 degrees, divided by 21.991 J ohms, and that will calculate out to 0.064 amps at an angle of negative 60 degrees. which is 64 milliamps at an angle of negative 60 degrees. So these are currents, and if I were to add these currents via complex numbers, okay, do this, we would find that we would get back to our total current of 0.096 amps at an angle of 19.392 degrees. So make sure you use your calculator to solve for these, and it's always a good idea to check your answer. Make sure that it is correct, because the calculator will check it very quickly for you. You shouldn't get this wrong.